Hello? Okay. Hello, everyone, and I'm Tang. I'm from China. I'm a SPIN PhD student at MU. And my current research is rotational motions of surface waves in weakly anisotropic media. So, we look at the left figure, we can find that the faster wave direction is associated with the flow direction. So, the azimuth entropy is very important to find the flow direction. Actually, for the traditional method, we use actual source data or virtual source data to research the azimuth entropy. That will be affected by the heterogeneity or entropy in the propagation path. So the question is, can we research the localized azimuth entropy? So if we can measure the rotational motion, can we get the answer? So starting from the polarization of surfaces, we can find in the isotropic media the really well polarized in the vertical and the radial plane. And the rotation is a linear polarization. However, in the anisotropic media, we can find the polarization direction of really well deviated from the propagation direction. And the rotation is become elliptical polarization. So we can use the translation to find the polarization direction and use the rotation to calculate the propagation direction. And we can combine these two angles to get the rotation angle. And this rotation angle, the tangent of this rotation angle can show the azimuth entropy, which can be used to constrain our localized azimuth entropy. So, comparing the polarization of translation, strain, and rotation, we can obtain the dispersion formulas. And the blue terms come from the coupling term, which means that in the isotropic medium, the quasi-Rayleigh wave and the quasi-Lau wave will be coupled. So we have to consider the effect of the coupling term. So in order to verify the derived formulas, I use the analytical solution derived by Smith in 1973. And it's a two-layer model. And the entropy is 5% for body waves. We can to find the result. The left figure is the result of quasi-Rayleigh wave, and the right figure is the result of quasi-Lau wave. And we can find the theory results and the ratio method, the result from the ratio method that match very well, which means that the derived formulas is correct. So conclusion, in theory, we can use the rotational motions to research the localized azimuth entropy and to find the flow direction. And it can provide the rotation angle and the azimuth-dependent dispersion information. So the biggest challenge is how to use the file data or do some experiments to verify the theory. And I plan to use the thin ring laser rotation motion to test the theory, but it will be very difficult. So yeah. And the coupling term between the quasi-Rayleigh wave and the quasi-Lau wave also affects the calculation of dispersion. So if you are interested in my research, we can discuss on my poster. Thanks.